The James Webb Space Telescope's finding has enthralled both the public and scientists. The telescope picked up what seemed to be lights coming from a big city. The telescope focused its observations on Proxima Centauri, the closest exoplanet to our solar system, and discovered enigmatic bright flashes that raised the intriguing question: could they be signs of an alien civilization? The discovery made by the James Webb Space Telescope has captivated both scientists and the general public, sparking widespread intrigue and excitement. The telescope, designed to observe the universe in unprecedented detail, recently detected lights that appear to emanate from a location resembling a city, shining brightly from a distant point approximately 4 light-years away. This extraordinary observation has reignited global interest in the possibility of extraterrestrial life. Specifically, the telescope focused its powerful instruments on Proxima Centauri b, the closest known exoplanet to our solar system. It recorded mysterious bright flashes that have raised the tantalizing question: could these lights be evidence of an alien civilization? For decades, humanity has speculated about life beyond Earth, and now the James Webb Space Telescope may have brought us closer to that long-awaited confirmation. The idea that we might not be alone in the universe has always inspired wonder, and the recent findings represent a potential turning point in our understanding of life in the cosmos. While scanning deep space, the telescope observed something truly remarkable on Proxima Centauri b, a rocky exoplanet that orbits the star Proxima Centauri. The lights detected resembled those of Earth cities when viewed from orbit, leading to a compelling hypothesis that an intelligent civilization might exist on that distant world. Scientists across the globe are energized by the implications of this observation. If confirmed, such lights could suggest the presence of beings capable of constructing organized societies and complex infrastructures. The city-like illumination located a staggering 4 light-years away has left NASA engineers and astronomers astonished. It raises the question of how long these lights might have been visible in space, silently awaiting the day when human technology advanced enough to detect them. David Kipping, an astronomer at Columbia University, has described Proxima Centauri b as a particularly complex and intriguing planet. Unlike many rocky planets that absorb sunlight and emit energy primarily as infrared radiation, this exoplanet demonstrates a unique thermal behavior due to its dynamic relationship with its host star, Proxima Centauri. The James Webb Space Telescope's powerful ability to detect infrared wavelengths was crucial in identifying these unusual signatures. This capability enables researchers to explore the planet's atmospheric conditions and search for evidence of habitability or even intelligent life. The telescope's extreme sensitivity to infrared light allows it to observe phenomena occurring during Proxima Centauri b's nighttime, something most telescopes struggle to achieve due to the immense challenge of detecting faint light in the vast darkness of space. The telescope's design makes it ideally suited for confirming whether the supposed artificial lights on the dark side of Proxima Centauri b are real. One particularly compelling feature of the James Webb Space Telescope is its ability to detect artificial light if it exists within a very narrow frequency band, one much narrower than the broad emissions typical of natural stellar light. The relationship between Proxima Centauri b and its star is thought to be tidally locked, meaning one side perpetually faces the star while the other remains in darkness. As the planet revolves, it experiences cyclical temperature changes similar to day and night on Earth. These cycles result in significant temperature variations, which are influenced by the planet's composition and potential atmosphere. If the planet lacks an atmosphere, the temperature differences between the two hemispheres would be extreme. The sun-facing side would be scorching hot, while the dark side would plunge to sub-zero temperatures. Without atmospheric gases or oceans to redistribute heat, these dramatic thermal contrasts offer scientists valuable clues about the planet's atmospheric composition. The James Webb Space Telescope's precision in detecting thermal emissions allows researchers to analyze the planet's heat signatures and determine whether an atmosphere exists. Interestingly, the telescope's orbital path around Earth aligns well with Proxima Centauri b's orbital period, enabling consistent observation of its complete daylight cycle every 11.2 Earth days. If an atmosphere is present, scientists plan to examine its chemical makeup in detail. Detecting elements such as oxygen, water vapor, and methane would indicate potentially habitable conditions. To identify these components, researchers analyze how light from a host star passes through the planet's atmosphere, a technique known as transmission spectroscopy. Although this task is incredibly complex, the James Webb Space Telescope is uniquely equipped to carry it out. While the telescope excels at characterizing planetary atmospheres, it does have limitations, particularly in detecting free oxygen, a vital biosignature. However, it can detect related compounds like ozone, which also point to a healthy, potentially life-supporting atmosphere. As researchers continue to analyze data from the telescope, the search for distant life-hosting worlds intensifies. Each observation brings humanity closer to answering one of its most profound and enduring questions. Are we alone in the universe? It's worth noting that despite the telescope's advanced capabilities, it can only observe a limited number of exoplanets close enough to Earth for detailed atmospheric analysis. To broaden our reach, astronomers are preparing to rely on upcoming ground-based observatories such as the Extremely Large Telescope, ELT, which is expected to begin operations in 2028. Deeper insights into the atmospheric structures of distant exoplanets, supplying clearer and more precise data that could further refine our understanding of their potential to harbor life. Simultaneously, the development of next-generation space telescopes aims to overcome current limitations and enhance our ability to observe distant worlds. One major obstacle in exoplanet observation is the overwhelming brightness of their parent stars, which often drowns out the faint light reflected by the planets themselves. To address this issue, scientists are working on innovative technologies such as coronagraphs and star shades. Coronagraphs are devices placed within telescopes that block out starlight while allowing the light from orbiting planets to pass through. By manipulating the light waves carefully, coronagraphs dramatically reduce stellar glare, making it easier to detect dim planetary light. Equally promising is the star shade, a massive flower-shaped spacecraft designed to fly in formation with a telescope located tens of thousands of kilometers away. The star shade blocks the starlight before it enters the telescope, permitting only the light from exoplanets to reach the instruments. This technique requires extraordinary precision, including the ability to align the star shade with a telescope to fractions of a millimeter across immense distances. These advanced systems must also contend with challenges such as miniaturization, energy efficiency, and the harsh environment of space. Despite these technical hurdles, the potential scientific rewards are immense. Successfully observing and analyzing the atmospheres of exoplanets could lead to the discovery of biosignatures, chemical markers that may indicate biological activity. Beyond atmospheric analysis, researchers are exploring methods to directly image distant worlds in greater detail. Future telescopes equipped with advanced adaptive optics will be capable of compensating for distortions caused by Earth's atmosphere or minor telescope movements, producing much sharper and clearer images. When combined with starlight blocking technologies like coronagraphs and star shades, these improvements could make it possible to not only detect exoplanets, but also map their surfaces and study their climates. The development of such next-generation telescopes marks a monumental step forward in humanity's ongoing effort to determine whether life exists beyond our solar system. By increasing our ability to observe and understand distant planets, we edge closer to answering a question that has fascinated our species for centuries. These potential discoveries have the power to revolutionize our understanding of our place in the cosmos and redefine humanity's perception of the universe. The James Webb Space Telescope continues to push the boundaries of astronomical science, offering unparalleled insight into the vast, mysterious expanse of space. Its recent findings have ignited new enthusiasm within the scientific community and among the public, drawing us nearer to the answers we have long sought. As the telescope continues to gather and transmit data from the farthest reaches of space, it becomes increasingly apparent that its capabilities are paving the way for discoveries that may fundamentally transform our understanding of life and the universe. One of the most exciting aspects of the James Webb Space Telescope is its ability to study exoplanets located within the habitable zones of their stars, regions where conditions may support the presence of liquid water, a key ingredient for life. Proxima Centauri b, being both relatively close to Earth and within its star's habitable zone, stands out as a prime candidate for hosting life. The detection of potential city-like lights on the surface of this planet raises compelling questions about the existence of artificial structures or technology, possibly the hallmarks of an advanced civilization. Still, interpreting such data must be approached with caution. Natural phenomena such as bioluminescent microbial activity or specific geological processes could also account for the observed lights. To avoid drawing premature conclusions, scientists are applying meticulous methodologies to analyze the spectral signatures of the detected light. This involves comparing the patterns with those of known natural and artificial light sources, followed by a series of rigorous repeat observations to confirm the findings. This level of precision and scrutiny is essential to ensure that any claim about extraterrestrial life is based on solid, reproducible evidence. With each new observation, the James Webb Space Telescope brings us closer to solving one of the greatest mysteries of existence, and its role in this cosmic quest is only just beginning. As the analysis continues, scientists are emphasizing the importance of multiple lines of evidence before confirming any signs of intelligent life on Proxima Centauri b. While the apparent city-like lights are indeed compelling, researchers must consider alternative explanations thoroughly. For example, geological activity such as volcanic eruptions, surface reflections from mineral deposits, or even aurora-like phenomena caused by magnetic interactions with the star could generate luminous emissions that might resemble artificial lights from a distance. The possibility of atmospheric lensing or the reflection of light off high-altitude clouds must also be ruled out before the extraterrestrial hypothesis gains more credibility. Each scenario is being meticulously modeled using data from the James Webb Space Telescope and cross-referenced with known planetary behaviors across our own solar system and other observed exoplanets. This cautious, science-first approach is crucial to avoid false positives, especially when the implications of confirming intelligent life are so profound. Even with all these precautions, the implications of the discovery are difficult to ignore. If the lights are determined to be artificial in origin, they would suggest the presence of a technologically advanced civilization capable of manipulating its environment, generating energy, and possibly even communicating. Such a civilization may have developed in parallel or even in advance of humanity, existing under conditions that, until recently, we considered inhospitable. The realization that intelligent life could exist on a planet so close to Earth would be a paradigm-shifting moment, fundamentally altering how we view ourselves in the cosmos. It would impact philosophy, religion, geopolitics, and scientific priorities on a global scale. Already, the discovery has sparked renewed interest in the search for extraterrestrial intelligence, SETI, with radio telescopes being trained once again on Proxima Centauri in hopes of detecting any patterns or signals that might accompany the light emissions beyond the immediate excitement.